Hi guys, today's essential question we are going to look at what makes up matter. When we're taking a look at matter, essentially it is anything that has a mass and takes up space. So, you have a mass, you take up space, so you matter. Now what is mass? So if we're trying to figure out what qualifies as matter, we need to understand what mass is and what mass is not. Mass is different than what you weigh. When we weigh somebody, we're looking at the pull of gravity on it. When we're looking at mass, mass is the amount of matter that something contains. So mass is universal, it never changes. Weight, on the other hand, does. So if a person on Earth weighs 80 pounds, that takes into effect gravity on Earth. On different planets, we have different pulls of gravity. So on Mars, that same person would weigh about 30 pounds. On Jupiter, the person would weigh 187 pounds. But at all three of these different locations, the person's mass would stay the same at 36 kilograms. So what makes up matter? We have atoms, elements, molecules, compounds, and mixtures. When we take a look at an atom, the atom is the basic smallest unit of a chemical element. And up here in the corner we have a model of an atom. In the center of the atom we have the nucleus. The nucleus is just the center region where we find two important particles. We have protons and neutrons. And a proton is a particle that has a positive charge. Neutrons don't have any charge. So they make up the central point of the nucleus. And around the nucleus we have this cloud of particles called electrons. And electrons have negative charges. So when we put together the positive, negative, and neutral, when we end up having the same of each, we end up having an atom that doesn't have a charge. Now when a bunch of the same type of atom get together, we have elements. So an element is a unit of one or more of the same type of atom. And they're arranged on the periodic table. And you guys have probably seen these tables up in our science classrooms. So when we're taking a look at an element, one of these, we have oxygen as an example here, you will see the atomic number listed. The atomic number tells you how many protons are found in that specific atom. So if we have hydrogen here, hydrogen only has one proton in its atom. Helium would have 2. In this case, oxygen would have 8. Other things you'll notice on the periodic table, we have an element symbol. Every element has its own abbreviation, so for oxygen it's just the capital O, and then we have its atomic mass. Molecules are what we find when two or more elements are held together by chemical bonds. So they mix together here and make something completely different than the two would be separate. So we can take two of the same, where we would have 2 oxygen come together and we have O2. Or we would have 2 hydrogen come together and we would have H2. But the atoms could be different too. We could have an Na, or sodium, and Cl, chlorine, come together and it makes something called table salt. Or we could have 2 hydrogens and an oxygen come together to make water. A molecule is just 2 or more elements bonding together. Now that's different from a compound, because when we're looking at compounds, a compound is 2 or more different elements. So a molecule, they could be the same or different, but a compound, we have to have different elements bonded together. So water still qualifies as a compound. And then behind my picture here, we have a faded chain. That is C6H12O6. And this is an example in your foldable. We have the molecule glucose. So what happens here is we have 6 carbon elements, we have 12 hydrogen, and 6 oxygen bonding together to make glucose. So all compounds are molecules, but not all molecules are compounds. Now the last one we're going to take a look at is a mixture. And a mixture is a system made up of 2 or more different substances that they're mixed, but they don't bond together chemically. So we could take a look at cereal. If you like Raisin Bran, you have the raisins and you have the flakes. Those would be a mixture. If you have trail mix or chicken noodle soup, those would be examples of mixtures. And the 2 different types of mixtures that we need to look at are heterogeneous and homogeneous. So a heterogeneous mixture is a mixture made up of different substances and they remain separate. So that would be your trail mix. We could separate out the cashews and the M&Ms and the raisins, Or if we just have a bag of M&Ms and we want to separate out the colors, we can do that. In a homogeneous mixture, the pieces that make up the mixture are evenly distributed throughout the entire mixture. All of the components, every piece of that mixture, is in the same phase. So when we start talking about solids, liquids, or gases, all of the pieces are going to be all solid, all liquid, or all gas. An example of something like this could be milk, or the air, or rainwater. Things are mixed together, but they come together as one, and we can't physically separate them. Be sure to fill out your foldable notes and take a picture of the notes that you put in your notebook.